Okay, so we're trying to come up with a formula using the Pythagorean theorem, and I kind of sketched it. The picture, for example, tends a little nicer on the screen, but I'll use this one. And what we need to do is find a way. We said use the ruler posture. In other words, you can measure it any way you like by counting the spaces, basically. And so we're going to call this, we're going to call C. You notice that C has the same height up as A, so we know its value for y is y1. And we also notice that C has the same distance from the origin horizontally as B, so that's going to be the same x value as B. And so the question is, we need to get this side here and this side here. Okay? So let's do AC first. If we want the length of AC, remember the ruler postulate says you can take the absolute values of we're going to do x2 minus x1. Usually x2 is bigger than x1 in this case, so we're going to do that. So we're going to write x2 minus x1. Okay, so we got that distance. And we also know we're going to do the same thing here. We need the vertical distance, right? The vertical distance is going to be y2 from B to C. So this distance right here from B to C, it's going to be y2 minus y1. So B to C is y2 minus y1. Now that we know the distance from A to C and B to C, we already knew that AB squared is equal to AC squared plus BC squared, right? Or if you want to get rid of this squared here, you can make this a giant square root. Okay, so let's put that in there. How long is the distance from A to B? The distance from A to B is, well, didn't we say we're going to take whatever AC is? Whoops, I'm going to erase that. And we're going to put absolute value bars in there, which is x2 minus x1, right? And we have to square it. And I'm running out of space, so I'm going to write the y's down below. Plus, we have to do the y's. The y's are the BC's right here. So the BC's and the y's are going to be right there. I'm going to put them in there. Just like I took the x's and put them in right there because that was the AC's. Okay? So I'm going to get the absolute value of y2 minus y1, whatever that is, and I'm going to square it. So essentially we've come up with a formula for it. It's the Pythagorean theorem just applied to it. Now usually the formula will have you call this distance d, so you can get rid of this and call it the distance that you're finding. And the other thing that happens is, if you ask yourself, absolute value makes something positive, right? Always get, whoops, sorry, wrong screen. Always makes things positive. But if you square something, even if it's negative, you get a negative times a negative. That's, if you square it, you also get positive. So in a sense, these absolute value bars are redundant because when I square this, everything inside here, once I subtract it, whether it's positive or negative, it will make it positive. And when I square this, it will make it positive. And I'll add those things together and square root it, and we're only going to take the positive one. And so the formula then can simplify. And I'll write it down here in red, and I'll cover over some of my stuff. Okay, so the formula would simplify and be d equals the square root of x2 minus x1 squared plus, and I'm going to have run out of space, so I'm going to put it here, y2 minus y1 squared. There it is. There's the distance formula we just developed. It only took us about 6 minutes.